Hello guys, in this video I am going to give you a quick introduction into this new research which is called as BANG. BANG is a first of its kind GPU based ANNS method which works efficiently on billion scale datasets that cannot entirely fit in the GPU memory. ANNS stands for Approximate Nearest Neighbor Search, that is a subroutine in algorithms routinely employed in information retrieval, pattern recognition, data mining, image processing, and beyond. Recent works in this have really made some inroads, but still the growing volume and dimensionality of data has made things a bit difficult. But this method takes advantage of the architectural specificities of the new research. Also, it enables overlapping communication with computation while reducing the data transfer between the CPU and GPU over the PCI bus. In this paper, the researchers have also evaluated BANG using a single NVIDIA Ampere A100 GPU on 10 popular ANN benchmark datasets. Bang outperforms the state of the art in the majority of the cases. Notably, on the billion size datasets, they have significantly shown that they are faster than their competitors, achieving huge difference in the throughput, which is really good. The thing is that this the k nearest neighbor search problem is always been a thorn in the side, to be honest. Graph-based ANNS algorithms have been shown to be generally more efficient in practice at handling large data sets, but GPU implementation of these algorithms require strong graph data structures in GPU memory, which limits their ability to handle large data set. Even recent GPUs like the NVIDIA Ampere 1 A100 having 80 GB VRAM cannot accommodate the entire input data, which is primarily the graph and data inputs. So the prior solutions such as sharding, effectively implemented by GGNN, result in high memory transfer costs. Also, hashing and compression techniques can manage large data on single GPU by reducing data dimensionality or compressing vectors. But these approaches may have limitations when it comes to high recalls for massive data sets. Also, while multi-GPU configurations shown by GGNN utilize 8 GPUs and other approaches, but still it doesn't work. That is where this Bang approach works like a charm. It is a new GPU-based ANN search method designed to efficiently handle large datasets while billions of points that cannot entirely fit in GPU memory. Bang stands out by employing compressed data for accelerated distance computation on the GPU while maintaining the graph and actual data points on the CPU, enabling efficient ANNS on the large graphs. CPU transfer neighbor information to the GPU at every iteration of the search. Bang is executed in stages that can run in parallel on CPU and GPU, optimizing resource utilization and mitigating CPU GPU data transfer bottlenecks. Bang uses product quantization or PQ for compressing data and operates on the Vamana graph, which is a technique that has been previously demonstrated success in disk ANN. If you look at this diagram, Bang is performing approximate nearest neighbor search on a CPU GPU hybrid system where you can see that the complete workflow of the Bang. Given a set of available queries, Bang processes the queries in parallel by effectively using CPU, which is the host, GPU, which is the device, and PCIe data transfer link between CPU and GPU. And in this research, they have shown that they can harness the distinct capabilities of CPU and GPU efficiently and collaboratively use multi-core CPU and a single GPU for achieving high throughput even on billion scale data. As I mentioned earlier, Bang uses the Vamana graph index graph from disk ANN as the search structure on which to perform query lookups, which really makes it quite cool. So all in all, a really good research I think when it comes to practicality, the thing is that there is always an issue when you are running the vector databases on GPU, because the index has to reside within a GPU of that vector database, but GPU has a limited memory. But bang is a method that keeps the index on disk, which is the disk ANN, while the query action unfolds on the GPU, supported by many sophisticated optimization to manage the bandwidth between CPU and GPU. So I think that this is quite good, and it is full of engineering. The paper I mean, so I would highly suggest that you read through it. I'll drop the link to it in video's description. Really hat off to all of these researchers who have done great work from Microsoft India and IIT Hyderabad. Karthik, Sayam, Samesh, Harsha, and Jyoti. Stellar work. Thanks, guys. I hope that you enjoyed it. If you have any questions, please put it in the comments. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps. Thanks for watching.